From the banks of the Colorado River in Lake Mead to the homes and businesses in Southern Nevada, welcome to Water Smarts, the podcast pumping from the heart of Las Vegas, where we engage with the experts who keep the water flowing throughout Southern Nevada. I'm Bronson Mack.
And I'm Crystal Zuelke. From how we treat it, deliver it, use it, protect it, and conserve it, the Water Smarts podcast is all about water in Southern Nevada. We hope to make you a little smarter about the one thing that keeps us all connected: water.
Hey, Crystal, it's a great day today. How are you?
I'm doing good, Bronson. I'm excited to talk to our guest today. We are looking at research and development when it comes to our water supply and our water quality and our drinking water that we supply to the valley. I don't know, have you seen the video that our team recently produced? It's called We Carry and Clean Your Water.
Very informative, great video. I'm really glad we were able to get out there and get some video and some more background on all this good work that these really smart chemists and scientists do every single day to protect our drinking water.
Yeah, I really would recommend everybody go to our SNWA YouTube channel and check it out. It's very informative, and it really just gives everybody some insight into what goes into providing your drinking water and the standards that we treat our water with. We take a look at a pilot treatment plant that we have out there. So we get an in-depth look at ozonation and flocculation and filtration, some of the things that we'll talk about in this podcast, but also just the forward thinking that our organization does when it comes to research. And that's preparing for an unlikely event, that maybe a storm event that might impact our water supply or our water quality, and how we're prepared for that stuff. So this is good. I'm excited to talk to Eric today.
And that is 25 years of research and development. The R&D team just hit that milestone of a quarter century of leading edge research, protecting drinking water quality. They wear the white lab coats. These are real scientists, serious chemists that are dedicated to making sure that every time you turn on that tap, that water is delivered reliably and that it meets all of the Safe Drinking Water Act standards. And today we're going to talk to Eric Wert. Eric is the Water Quality Research Manager for the Southern Nevada Water Authority. His team is doing that work for 25 years to protect and enhance our drinking water. Eric, welcome to the Water Smarts podcast.
Thank you, Bronson and Crystal. Looking forward to the discussion today.
Well, I'm really happy to have you here, Eric. You know, you and I have had many conversations offline where we've talked about water quality. You've shared with me what the R&D group does, and it's just really impressive. And I'm glad that we get to share that with our audience here today because, Eric, on this podcast, we've talked a lot about how the Southern Nevada Water Authority runs hundreds of thousands of analyses on the water samples that get collected each year. And that's all to really monitor and protect the quality of the drinking water that gets delivered to our homes. I guess I would say that people might not know that the Southern Nevada Water Authority really is one of the few water agencies that has a world-class in-house research and development arm that helps ensure that SNWA and our community stays on the forefront of existing water quality issues, emerging water quality issues, helping us stay ahead of the curve. So can you just give our listeners a little bit of background on the Water Authority's Research and Development Laboratory?
Sure, Bronson. That's a great introduction. Our team conducts research studies to ensure that our treatment facilities can meet current regulations, as well as preparing us for future regulations. Most listeners are probably aware that the U.S. EPA regulates a variety of chemical and microbial contaminants. But before they make the list, there's a lot of research that's done on every one of those constituents. And in many ways, that's what we do here. We research things like occurrence of these contaminants, the treatment efficacy to remove them, to make sure that we're prepared for any potential regulation that may come up in the future. And as you said, we are very uniquely positioned here at the Southern Nevada Water Authority with a group like ours. We field a lot of questions from around the country and around the world about our model and the work that we do here and how we're structured and how we do what we do. The overarching goal, though, is to just make sure that we're providing high quality water to our customers so that the work that we do has relevance here in Southern Nevada, also around the country, as well as internationally.
And the SNWA does have a reputation, like you said, around the globe for being at the forefront of pretty much everything we do when it comes to water resources and water quality. Eric, there are so many improvements to our water system and discoveries that have come from, at least partially, the studies done by the Water Authority's research and development team. Before we kind of get into some of those success stories, explain how the research lab is staffed and how that benefits the community.
Yeah, good question. So the research team has been around for 25 years, and we started small with just a handful of 4 folks. And over the years, we've evolved to include more engineers, more chemists, some microbiologists that help us conduct all of our work. We also have some full-time staff that serve as kind of team leads in any one of those areas, engineering, chemistry, or microbiology. And each of those team leads has what we call postdoctoral researchers. So these are folks that will complete a PhD at a university, either at UNLV or around the country, or in a few cases internationally. And these folks come into our program for 3 years. 3-year limit. They conduct all the research. They publish a lot of papers. They help us meet our goals. And then they go on to find employment elsewhere. So they could go on to find a job at another utility, at a consulting firm. They might become a professor at a university somewhere. And some of them actually remain here with us here at SNWA, and we hire them as full-time employees. It's been a really interesting program. It really creates an influx of new ideas, on a variety of new contaminants or new technologies that we may want to take a look at here. And it also creates this alumni network around the country. So we have our own kind of SNWA alumni of these folks that come here and then go on to find future employment elsewhere. But not only PhDs, but we hire a lot of interns as well. And most of our interns come from local universities. So UNLV, Nevada State University, College of Southern Nevada. And they'll come in and they'll support full-time staff as well as the postdoctoral researchers in conducting a variety of water quality and treatment studies.
Well, that's great that you're able to bring on interns locally from our universities and our college system here. And then that's really interesting to hear about the PhD program. I have to imagine that is a direct benefit then to SNWA in the future as those former students or interns are going out into the workforce. We're able to keep those connections with those individuals, with the new agencies or the new companies that they work with. So that's got to also have kind of a boomerang benefit back to us, right?
Yeah, absolutely. A lot of the folks that move on to these other roles, we continue to collaborate with today. And also when they're in their new organization, and they start telling people about their background, they always talk about SNWA. And it really helps to assert us as leaders in the field.
Yeah. And with that leadership in the field of water quality, one of the things that the Water Authority did really early on in the 1990s was implementing ozone and the treatment of water utilizing ozone. And if I recall correctly, that's because there was a positive detection of cryptosporidium that was in a finished water supply sometime in the 90s. And let's be clear, cryptosporidium is not something that you necessarily want in your drinking water. And that's why there are these stringent water quality regulations and water treatment processes. As a result of that, the R&D team studied how to integrate ozone treatment into the water treatment facilities here in Southern Nevada, providing that additional level of protective barrier and really working effectively to destroy the microorganisms so that it didn't become an issue going forward. But Eric, I also understand that the SNWA lab and the R&D team have also been leading researchers for endocrine disruptors in water and wastewater. And that has led to, wastewater epidemiology discoveries that were used during the COVID pandemic and other interesting progress within the water quality field. Can you just give kind of a brief overview about some of this pioneering work that has been done related to endocrine disruptors, and then also with some of the wastewater surveillance activities that the Water Authority has done?
Yeah, back in the 90s, we had an outbreak of cryptosporidium. As a result, our board and general manager wanted to install the best available technology that was out there to protect our customers and to protect our water supply. And at the time, that technology was ozone, and it still remains the best available technology for cryptosporidium inactivation. So anytime that you install a major process like that into the treatment facilities, it takes a lot of work, not just on the design and construction phase, but also preparing our operations staff for how that process will run on a routine basis. We did a lot of work looking at different analyzers, process control strategies, and also the production of a disinfection byproduct of that process called bromate, which is regulated by US EPA. And through our pilot work, we were able to develop a novel strategy to minimize the production of that particular disinfection byproduct using a combination of chlorine and ammonia. And we actually received a patent for that work, which is pretty interesting. And that process is still in use 25 years later. So it's still our strategy to control bromate production. So a lot of that work was pioneered 25 years ago and still in use today. And the other arm of that, as you mentioned, was endocrine disrupting compounds. At the time, very few labs were able to detect that suite of contaminants. And it really put us on the map here at SNWA as far as having a very sophisticated analytical chemistry lab that we could look for these substances at nanogram per liter concentrations, very low concentrations. And it kicked off a whole suite of research looking at occurrence in Lake Mead, and then it kind of transitioned into the wastewater treatment plants. So we started looking at these different compounds and how advanced wastewater treatment could remove those constituents. And then advanced wastewater treatment evolves into water reuse, which is of national interest right now. So a lot of the work, even back then, 25 years ago, it's kind of evolved in that manner to where we are today. And it's still providing foundation for a lot of discussions by different states as they continue to develop water reuse regulations.
I love having these conversations because we talk about this all the time because we live this and breathe this in the water world that we're all in. But in general, a lot of people just don't understand all the work that goes into protecting and delivering drinking water to the community and the level of research and testing that goes into it. So I love having this conversation and how your research can and does improve the quality of our drinking water. But Eric, I'm curious about the impact it has on our pipes and treatment plants and other facilities, because that's another aspect that the community doesn't really get to see because a lot of our infrastructure is underground and how we move water across the valley to serve every single home and business in the community. What are some examples of research projects that have helped protect our water infrastructure?
Yeah, well, that's a great question. And definitely one facet of our program is infrastructure protection. A great example of that goes back to 2007, 2008, when we first discovered quagga mussels in Lake Mead. And at the time, the base of knowledge was in the Great Lakes region, Lake Michigan, Lake Huron, and so forth. And a lot of plants in that vicinity use the chemical called potassium permanganate to control quagga mussel infestation in their raw water pipelines. In our water, it really wasn't a good fit for us. So through our work, we were able to find a low-cost treatment strategy, again, involving chlorine and ammonia, the same strategy that we used for bromate control. We apply that same strategy to mitigate or prevent quagga mussels from attaching to our raw water infrastructure. So we implemented that in 2008 or 9, I believe. And that strategy is still in use today and still providing very good protection of our raw water pipeline. So we could also look at the distribution side of things. The makers of different plumbing materials, they'll change their material compositions quite frequently. And it could be based on the price of different materials at the time or whatever. Bismuth may be cheaper than zinc or what have you. But they'll change that chemical composition. And while some agencies may approve those formulations, we try to take a look at them here to see how they'll respond to Colorado River water, to see if they'll withhold their robustness. So we do a lot of testing at pilot scale. And I guess I should mention, we work at different scales. Bench scale, which is an experiment you could do on a bench top. Pilot scale, which is a smaller treatment system. It flows continuously at a few gallons per minute. And then we also do some full-scale optimization studies. But a lot of our corrosion work we do at pilot scale in a smaller flow-through type system, so we can control different conditions and just see how these different material types will hold up in our water.
Well, that's really interesting to hear about the corrosion control aspect. I mean, I think most of our listeners are familiar with Flint, Michigan. They have an understanding that the change of the water chemistry caused some corrosion to occur within the municipal water system. That then led to the lead contamination from the lead service lines. Fortunately, we do not have lead service lines here in Southern Nevada. But even though we don't have lead service lines, corrosion is still a potential concern. So the testing that your team is doing there is helping to ensure water infrastructure is not negatively reacting with the chemistry of the Colorado River water and what we're delivering to customers. That keeps that water system reliable over the long period of time. You know, I really appreciated your summary there on ozonation as well, and that being a really advanced water treatment process that we do here. And I think you even said that it's deployed by other municipal water providers throughout the United States and really all over the world, SNWA being an early adopter there. Eric, your R&D team has most recently been looking at UV technology, the use of ultraviolet light and LEDs to see how that further helps to benefit the treatment of drinking water. Can you tell us a little bit about that project? Because I've got LED lights at my house. Are you telling me that I've got water treatment right there at my house?
I don't know about that, but
okay.
But yeah, we do take a look at UV treatment right now, particularly on our groundwater supplies, the supplies that are smaller in scale. And UV treatment has been around for decades, much like ozone, and often entails using mercury-based lamps, which is kind of a drawback to that technology. It's kind of the generation 1 technology, if you will. Now we're moving into generation 2, which are the LEDs. Here at SNWA, we've been doing testing over the last 4 or 5 years at both bench scale and in the field with UV LED reactors. So we can move away from those mercury-based lamps and go to LEDs. And at the particular wavelength of light that these UV LEDs emit, it disrupts the DNA of different microorganisms, rendering them inactive. So it's a very good disinfectant, if you will, or an inactivator of microbes. So they make for really good systems. They're kind of plug and play on smaller systems like our groundwater wells, where we're looking for that extra barrier for disinfection. Again, just providing our customers with high quality water. And this technology in particular, and the work that we're doing here, I think is industry changing, because as a lot of these systems that have used mercury-based lamps, they're all getting to be 20, 25 years old. So as they become due for replacement, they will look to the work that we're doing here in Southern Nevada to basically vet this technology so that they feel more confident in adopting it for their system.
Bronson, I'm just going to say, leave the water treatment and all that good stuff to the SNWA.
I know, right? You got to leave it to the experts. So
yeah,
don't try and build your own home house filtration system with light bulbs.
No, definitely not. So, Eric, when we talk about emerging issues in the water world, one of the things we should probably talk about is PFAS. And I'm always don't know if I'm saying it right because I'm not a scientist, but I've heard it said different ways. But PFAS are tiny particles that come from manufactured chemicals used in many products like nonstick cookware, stain repellents, and other waterproofing items, even water-resistant jackets. PFAS are also used in industrial items like firefighting foams and electronics. We hear a lot about them in the news these days, and I know some people are concerned about them finding their way into Lake Mead, our drinking water supply. What has the Water Authority been doing to address these compounds, also known as forever chemicals?
This is another example where our team started researching this issue close to 15 years ago. Back in 2008, we started developing the analytical methods to start looking at PFAS occurrence as well as treatment technologies for not only our water supply, but nationally. What would work to remove PFAS if we would need to do that in the future? Fortunately, what we found is that our water supply has very little PFAS in it. And if you think about the Colorado River watershed, it starts as snowmelt in the Rockies, travels down through the Grand Canyon and before it reaches Lake Mead. So there are very few industrial processes that take place within that region of the Western U.S., very few wastewater discharges. So we really have a pretty pristine water supply, and that really leads us to have very low concentrations of PFAS. But still, we do a lot of research on treatment technologies. We've received a lot of external funding from different agencies to do that work, since we have that capability here at SNWA. So after conducting years of research on the topic of PFAS, we are looked to as a national leader on the subject.
Related to that, I mean, PFAS being one of those emerging issues that we see within the water quality space. You mentioned the US EPA, and ultimately the EPA is the regulatory body, if you will, that protects human health and the environment from harmful pollutants. And they also enforce the standards associated with the Safe Drinking Water Act. As a water agency, we have to meet those strict standards to ensure that we stay in compliance with the Safe Drinking Water Act. Eric, just for our listeners' knowledge, the Safe Drinking Water Act sets the standard for more than 90 contaminants that can be present in drinking water supplies. Is that about correct?
Yeah. US EPA regulates a lot of different chemical and microbial contaminants. It also sets a lot of treatment standards that we have to abide by. And for everything that EPA is on EPA's list right now, our treatment facilities do a great job of handling everything that's regulated at present. On that list of contaminants that you mentioned, we try to look at that and get out our crystal ball and look out into the future to see how changing water quality conditions might affect that. So anybody that's been out to Lake Mead recently, has seen, we're still in a drought. So we look at things like increasing temperature and how that increasing water temperature might limit our ability to meet our regulatory goals and to still meet our water quality objectives. On the other side of that, EPA also publishes what they call an unregulated contaminant monitoring rule. And that kind of gives you a roadmap for where EPA is going as far as what they might regulate in the future. So we also pay close attention to that list of contaminants. Right now, they have a lot of different PFAS compounds on there, as well as lithium. So that's an example of something you might ask what we're doing right now. So lithium was included on that list. So we actually have a funded research project right now with the Water Research Foundation, where we're going to take a deeper dive into looking at lithium occurrence as well as different treatment strategies should EPA decide to regulate that contaminant in the future.
And all of that is to make sure that your drinking water coming out of your tap is meeting or surpassing those strict standards of the Safe Drinking Water Act at the federal level, at the state level. Eric, thank you so much for joining us here on the podcast and making us a little bit smarter about your water research.
Awesome. Thanks for having me, Bronson and Crystal.
Well, Crystal, I don't know, maybe I'm just a geek, but I like hearing about this water quality stuff, knowing all of the science that goes into it, and like just that assurity that you have that, yeah, you can take a glass of tap water, you can drink it, you can make some Kool-Aid and some lemonade with your tap water, and you can do that with the confidence that it's safe to drink.
Yeah, I mean, just like we talked about earlier throughout the podcast, it's just something that everybody takes for granted. I know I do. Even working here as an employee, I don't necessarily think about it every day when I turn on my tap to make my cup of coffee. But it's so valuable, I think, for everybody to understand the work and the treatment and the research that goes into providing high quality drinking water to the whole community. One of the things I wanted to touch on that Eric brought up is we were talking about chlorine and the advancement that has brought to water treatment. I know we hear from some people about the taste of our water, or they can smell chlorine in their tap water. And so that makes people a little nervous. Sometimes they don't know if that makes their water less safe. What do you, what do you bring from that? Because I know that I know we hear it a lot.
Yeah. Yeah. And it kind of depends on where you are within the valley and where you are connected to the distribution system. But certainly, yeah, you can detect a little bit of chlorination in the water. I think most people are detecting that when they're sitting in a bathtub, and you've got that water there and you're interacting with it a little bit more than when it's just coming out of your tap. But the key thing to remember is that the chlorination of the water, the little bit of chlorine that is added to the water, helps to ensure that bacterial growth doesn't happen within the 7,000 miles of pipeline throughout the valley that's delivering drinking water. So it is a way to protect the pristine water quality coming out of the treatment plants, protecting that water quality as it makes its way to your tap. And in fact, in 1997, Life magazine actually declared the filtration of drinking water plus the use of chlorine as probably one of the most significant advancements in public health. I mean, we don't hear about people getting waterborne illness from tap water, and that's because chlorination, filtration, and the other water quality, water treatment processes that we heard Eric talk about today. So, well, that's it for this episode here on the Water Smarts Podcast. We hope you subscribe and listen next time. And if you like the show, give us a rating. It really helps us to reach more Southern Nevadans. And if you'd like more information on conservation, water quality, new technologies, and everything you need to know to be water smart, you can find those tips, videos, and helpful hints at our website, SNWA.com. Thanks for listening, and we hope you join us here next time on Water Smarts.